Hello everyone. Today we're going to be doing the LCM of polynomials. So we have added and subtracted rational expressions with like denominators. When we get to unlike denominators, we're going to have to deal with the LCM, which is why we're going to talk about it first. So lowest common multiple. If you kind of remember back to elementary school, a little bit of middle school, if we deal with the LCM of integers, it's the first multiple they have in common. So if I was thinking of multiples of 2, 4, 6, 8, 10, 12, 14, and so on. Multiples of 5, 10, 10, 15, 20, and so on. So if you look for the ones they have in common, that was a 10, which means their LCM, the first multiple of 2 and 5, is 10. If we dealt with the LCM of 6 and 8, the multiples of 8 of 6, 12, 18, 24, 30, 36, and so on. For the multiples of 8, 16, 24, 32, and so on. And I'm going to stop there because their first multiple they have in common is 24. So we're trying to find the first multiple that they have in common. So that's just plain numbers, integers. We also are going to be dealing with the LCM of monomials, which includes integers. So we're going to use that concept. But with the variables, we are going to use the largest exponent available. So let's say number 3. We have 8x squared y minus 12xy cubed. First, 8 and negative 12. The first multiple of 8 and negative 12 is negative 24. If there's a negative, you just use the negative. Okay? 8 times 3 is 24, 12 times 2 is 24. Now, there's x values. If we look at the x's, the highest exponent is a 2. So that one's going to be an x squared. And the highest y value is a 3, so it's going to be y cubed. Now, here's why we care about this. We are going to be having to multiply so that they have the same denominator. So what I would multiply this one by is a negative 3, the x's are fine, and a y squared, and I would get my LCM. For the other one, I would multiply it by a 2 and an x to get my LCM. We can't have an exponent that's smaller, and we can't leave off variables because we can't just make them disappear. When we're multiplying, we can add to them, but we can't make them go away. So that's why we take the highest exponent and we make sure we have every piece available. So if we look at number 4, the first multiple of 6 and 4 is 12. One of them has a c, so it has to be part of the common denominator, and it's a c squared. They both have the variable d, and the highest exponent is a 3. So if I were to multiply 6c squared d to make it into the LCM, I'd have to multiply 6 times 2 to make 12. The c squared's already a c squared. And I'd have to multiply by a d squared to make it a d cubed. If I were to multiply 4 by something to make it a 12, that would be a 3. I don't have a c squared, so I'm going to have to multiply it by a c squared. And d cubed is already there, so it's fine. So we're trying to find what we can multiply them by to make them the same. Now, when it comes to polynomials, there's a couple of things that we're going to do. We're going to use the highest exponent of each factor, which means the first thing we're going to have to do is factor it if it's not factored. We are going to then match common factors, and we're going to include one of them in the LCM. The factors with no match are also included in the LCM. So on number 5, if we look at this problem here, you'll notice that they're already factored. X plus 1 and x minus 1 are already factored. You have to consider x plus 1 as an entire term, an entire factor, and x minus 1 as an entire factor. It's kind of like when we're reducing rationals, you can only deal with monomials and binomials with binomials. These are not the same binomial. So these are actually called relatively prime because they are not the same thing. So when something is relatively prime, it means they don't have anything in common, and your LCM is just multiplying them together. It was kind of like on the very first problem when we dealt with the numbers 2 and 5. They don't have anything in common. You can't divide them by the same thing. They are relatively prime, so their LCM was whatever 2 times 5 is, which was 10. So if something's relatively prime, it has nothing in common, your answer is just to multiply them together. Oops, that should be over there. Okay? So let's try another one. Number 6. First, we're going to factor. X squared minus 9 is x plus 3 times x minus 3. The other trinomial, we need to find two numbers that multiply to negative 15 and add to 2, which is 5 and negative 3. Now the way that I'm going to write this, I'm actually going to line up stuff that matches. This is going to help me in the end decide what my LCM is. So x plus 5 times x minus 3. So I'm going to line up the x minus 3's, but the other one doesn't have an x plus 5, so I'm just going to write it over here. My answer for my LCM ends up being x plus 3 times x minus 3 times x plus 5. So it is x plus 3 times x minus 3 times x plus 5. Because if I were to fill in the missing pieces, I would have to multiply the top one by that x plus 5 because that's needed, and this bottom one by x plus 3 because that's needed. They both already have an x minus 3, so they're fine on that one. But if I did multiply those by what I have in the purple, then they would be the same exact polynomial, which is what we want when we're going to come to adding and subtracting with unlike denominators. So we did not have to put two x minus 3's because they already had that in common, so it was just part of our answer. So lining things up can be very helpful, so I highly suggest that you do that while you are working on this problem. Okay, let's try one more. Oh, just kidding. We're going to try two more. So this first problem, we need to find two numbers that multiply to 9 and add to 6, which is 3 and 3. So I can either write this as x plus 3 or x plus 3 squared. Either way is totally fine. In the other trinomial, I'm looking for two numbers that multiply to negative 18 and add to negative 3. So that would be negative 6 and positive 3. So I have an x plus 3, but I only have one of them, and I have an x minus 6. So this goes back to the highest denominator. So while these two are the same trinomial, the highest of its exponents is that 2. So the LCM is going to have an x plus 3 squared, but it also has an x minus 6. Because I need to fill in this gap right here with the x minus 6. Okay, let's try one more. If I were to find two numbers that multiply to negative 20 and add to negative 1, that'd be negative 5 and positive 4. So x minus 5 times x plus 4. The other binomial, can't factor that. It just is x plus 4. So I can match those ones up right here. And all I'm missing is this one right there. So what ends up happening for something like this is the LCM can be one of the problems. So that would be the LCM. So you're trying to match up like binomials and fill in all of the missing pieces. If you have a monomial, you're thinking of the highest exponent and the first multiple of the coefficient. So your word of the day is multiple because you're trying to find common multiples. Your assignment is the least common multiple of polynomials, and it is due on Thursday, April 9th. Let me know if you have any questions, and have a great day.